Transformations. This lesson is on piecewise functions. You'll be able to graph a piecewise linear function, write the equation of a piecewise function, use interval notation to state the domain and range of the graph, and evaluate a piecewise function for a given input value. Lots of stuff. Let's get started. First, a piecewise function is a function defined using different rules for different intervals of the domain. Find the domain that the value belongs to when you're evaluating, and then substitute that value into the equation. Okay, this is sort of like if you go to a movie theater, and if you are under 12, you get in for a child's ticket price. If you're 12 up to, say, 60, you get in for the normal price. If you're over 60, then you get in for a senior citizen discount. So you've got to find the domain. The price differs based on the input age. So piecewise function, the output or the function used to evaluate for the output changes based on the input. So let's take a look at first evaluating, since that's the easiest thing to do with piecewise functions. Here we have our function. It has two pieces. I want to find the value of each. F of negative 2. Well, first I have to ask myself, negative 2, is that less than 2 or greater than or equal to 2? It's less than 2. So that means I'm going to do 1/2 negative 2 times negative 2 minus 5. 1/2 times negative 2 is negative 1 minus 5 is negative 6. That's my answer. F of 2. Well, is 2 less than 2? No. Is it greater than or equal to 2? Yes. So I'm going to use this function. So I'm going to put in 2 plus 3. And my result here is 5. F of 4. Is 4 less than 2? No. Is 4 greater than or equal to 2? Yes. So I'm going to use the second piece. I'll replace the x with the 4, add 3, and my answer is 7. Okay, for number 2, I have 3 pieces. Now notice the first piecewise function, it was completely linear. The second piecewise function is not necessarily just linear. It's linear and absolute value both. So let's take a look, and there's 3 pieces. G of negative 8. Is negative 8 less than negative 6? Yes. So I'll do negative 8 minus 5. That's 8 minus 5 is 3. Is 1 less than negative 6? No. Is it greater than or equal to negative 6 and less than 4? Yes. So I'm going to use this middle piece. So I have the absolute value of 1 plus 3. That's the absolute value of 4, which is 4. 6. Is 6 less than negative 6? No. Is it greater than or equal to negative 6 and less than 4? No. Is it greater than 4? Yes. In this case, my answer is just negative 5. This piece says anytime x is greater than or equal to 4, your answer is just negative 5. It's easy. It's a constant. Okay? Alrighty. Graphing. Now to graph, right, you're going to identify all the change of behavior values. Those will be the values where things change in the given domain. Find the y values for all the functions at that change of behavior and determine if those points will be open or closed circles, and then plot them on your graph. Graph the equations in the piecewise defined functions, but make the graph only appear where the domain states the equation exists. Now, to watch a video in class, we're going to watch this video. So did I get it? No. So if I click on it, it goes to a YouTube video. So we're watching a video of a video. Woo! Aren't you lucky? Right? What I want you to notice And I'm going to
graph some piecewise functions.
Pause this because I'm going to go ahead and do more on the ones that we have. You can watch this yourself. What you need to do is look up here, https://www.youtube.com/watch. Question mark V equals Q, capital L, ZW, capital P, capital W, capital E, PM, capital M, lowercase g. Take this tag and put it in. It's Algebra 2, graphing a piecewise function. Okay? If you want to watch this video as well as the rest of my video, that's great. Notice over here, a lot of possibilities of doing piecewise function. Okay? So again, take a look at this, copy it down, pause the video. You can go and watch this video as well if you prefer that to looking through the examples that I'm going to continue with. Okay? Oops. So, let's go here, piecewise functions. Now, in that video, you're going to learn that each piecewise function, you take it one part at a time, and you decide if it's linear, it's great. You need two end pieces. If it's not linear, then you got to know the parent function. So, let's go ahead and do these two. This first piece that I'll do in red goes from -1 to 2. So my x values will be -1 and 2. I also know that at -1, I'm going to use a solid point, and at 2, I'm going to have an open point because it comes up to but doesn't equal it. So, and okay, I'm just double checking. Sometimes I do crazy things. At -1, when I put -1 in, 3 times -1 is -3 plus 2 is -1. If I put in 2, it doesn't really belong in this top one, but that's why it's the open dot. 3 times 2 is 6 plus 2 is 8. So I'm going to go to -1, -1, put in a solid point. I'm going to go to 2 and 8 and put in an open point. Now, because it's linear, I can just connect those with a line. Using an index card or something helps. The next one is greater than or equal to 2, and it goes up to 5. When x is 2, -2 plus 8 is 6. -5 plus 8 is 3. At 2, I'm using a closed point. At 5, I'm using an open point. So 2, 6, closed point, 5, 3, open point, and I connect them. And I'm done. This function does not exist before -1 nor after 5. All right? That's all you have to do to graph that piecewise function. Each piece, you just graph it over its part of the domain. Now this one says that when x is less than 1. So I know 1 is the biggest value I can have, and it's going to be a little open dot. But I can keep going less than 1 forever. So to get a starting point, I'm going to pick any value less than 1. Let's say -3. Now, I'm going to use an arrow, not an open dot or a closed dot, an arrow, because while I picked -3, -4, -10, -20, all of those are less than 1. So it could keep going. So if I put in -3, 2 times -3 is -6. 1 times 2 is 2. So I come out here to -3 and -6, and I'm going to put a little point. Not a big point, still a point. Then at 1, 2, I'm going to put an open dot. Now, I'm going to draw my line down to that point, but then I'm going to put an arrow on it to say it keeps going in this direction. And by the way, on your papers, you should use a straight edge. I can't use a straight edge on my computer. It doesn't work that way. For the purple one, y is always equal to 4. So when x is equal to 1, y is 4, and it's just a single point. So here's my single point. There isn't any before or after 1. It's only at 1. Does x equal 4? When x is more than 1, okay, it's in red. When x is more than 1, I obey x plus 5. So 1 plus 5 is 6. Now I have to, and this is going to be an open dot. And now I'm going to pick any other point more than 1. In this case, I might pick something like 3. 3 plus 5 is 8. What will I use here? Well, I had to pick this value. If I have to pick it, it's going to be an arrow, because that means I picked it. Somebody might pick one bigger or smaller than mine. So at 1, 6, I have an open point. At 3, 8, I'm going to put a little point, and then I'm going to connect through that point and put my arrow. There's my piecewise function. Notice it is a function because at 1, when I draw a vertical line, the purple dot is the only thing that exists there. Okay? Oops, let me make sure I didn't have more there. Oh, yes, domain and range. Okay, so the domain, let's go back to this first one. The domain here starts at -1, and its highest and its farthest point to the left is 5, but it doesn't actually equal 5, so I'm going to use a parenthesis. The range starts down here at -1, and it goes up to, but it does not include 8. The red section is increasing. This is something else you might be asked. Increasing is from -1 to 2. The graph is decreasing from 2 to 5. It's over what values of x is the slope going up or down. Okay, the next set over here, this one's a little bit easier. The domain, it keeps going forever to the left, forever to the right. That's -infinity to +infinity, left to right. The range keeps going down forever, keeps going up forever. -infinity to +infinity. And why in the world did I, goodness, got a little brain fart there. I don't know why I put things there. Should just be little comma. Okay? Now this one is increasing from, it's increasing -infinity to 1, and then from 1 to +infinity. At 1, it's constant, but it's kind of weird because it's only a single point. Now, writing. Writing. Identify the different domains shown in the graph. Write an equation for each domain specified by the lines in the graph. Now, this is something where eventually we're going to learn this V shape is an absolute value. But right now, we're going to write it just as lines. Okay? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, good. Make sure I gave myself enough spaces. So over here, I'm going to look at each piece first. So I'm going to look at this piece. This piece is going forever to the left, and it's less than -3. So x is less than -3. Now I have to write the equation of the line. Well, this line, it's got a slope of 1, so it's x. And then it's going to keep going, 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 and it's going to cross at -1. Okay? You find the equation of the line. You can do that by 2 points. Find the equation of the line. You can count the slope, rise and run, and extend it on up until it hits the x or the y-axis. The next piece is going to be from here down to here. Now, at this spot, it's either solid for the green or open for the green. This is where it doesn't matter to me. So this goes from -3 less than or equal to x, which is less than or equal to 0. We're going to make it open or closed for the green. This one is negative x. Notice your slope is -1 and it's crossing at -2. This next one over here has got a positive slope. It's crossing at -2. Don't know why that bumped up there. And where is it going? Well, it's got an open point here, goes up to an open point here. So 0 is less than x is less than 3. When you've got an open on top of a closed wins. So when I write it, either this one's got to be less than and this is less than or equal to, or vice versa. They can't both be equal because you can't be equal, you can't apply to both. Finally, we have our fourth piece, which goes from here, whoops, out to here. It's constant. It goes from 3 to 10, and I've got solid points, so I'm going to use less than or equal to, and it's just 4. I've written the equation for my piecewise. This next piecewise, okay, same thing. We're going to do this piece first, and I'll make that solid there. So this is x is less than -5, and so that I can actually see this line. Oops. Okay. This line has a slope of -2, and going to be at -12, -14. There's the equation for the line. So x is less than, now then at, do the green, -5 less than or equal to x less than 2. That would be this section right here. This is going up by 2, so it's a positive 2x. And this is crossing at 6, so plus 6. The next piece is this little point here. That's happening at 2 equals x, or x equals 2. It doesn't matter which way you want to write it. And that's just a point where the y value is 5. Then, when x, oops, because I want to keep it color coordinated. When x is greater than 2, this is a negative slope, it's -x. So boom, boom, plus 4. And I'm done. I've written the equation. Excuse me. Excuse me again, allergies. I've written the equation for each piece of the domain for the piecewise function. Okay, why are there piecewise functions in the world? Just to make life miserable? No, lots of things are piecewise. Let's look at some examples. So, a physician bases her fee on the length of time she spends with a patient. If she's with you less than 6 minutes, it's only going to cost you $50. If she's with you for 6 minutes up to and including 15 minutes, it's going to cost you $80. Over 15 minutes will cost $80 plus $5 per minute above 15 minutes. So, if you go in, you can only see your nurse greater than 0, or your doctor greater than 0, less than 6. If you don't see your doctor at all, you don't pay. Okay? Pay the doctor. So from 0 up to less than 6, not equal to 6, but less than 6, you're just going to pay $50. From 6 minutes up to and including 15 minutes, boom, this should be 15. You're going to pay $80. And then If you go over 15, you're going to pay the 80 plus $5 per minute in excess of 15. So the first 15 minutes are covered with the 80, but then you're going to pay $5. Now, questions? You are now the office worker, and somebody's appointment was only 5 minutes. How much will this person pay? Well, this person will pay 5, so that's there. They're going to pay $50. 12 minutes. 12 is between 6 and 15. So this person will pay or owe $80. Finally, we have 20 minutes. Well, 20 minutes says that they're going to owe 80 plus $5 per minute over 15. So they had a total of 20. Take away the 15 that was covered here, and you wind up owing $105 for your visit. Okay? Next up, your favorite dog groomer charges according to your dog's weight. If your dog weighs 20 pounds or less, the groomer charges 30. If your dog is between 20 up to and including 45 pounds, she charges 40. If your dog is over 45 pounds, she charges $40 plus $2 for each additional pound over 40. So again, if you are greater than 0, you can't have a dog that equals 0, okay? But less than or equal to 20, flat fee. If it's greater than 20, but less than or equal to 45, it's 40. And anything over 45 pounds, well, you're going to pay 40 plus 2 times W minus 45. Your dog weighs 20 pounds. If your dog weighs 20 pounds, lucky you, it's the most it can weigh and still just pay $30. Your dog weighs 45 pounds. Again, lucky you, you're at the top end of your $40. Your dog weighs 60. That's going to be 40 plus 2 times the 60 minus the 45. This will be 40 plus 2 times 15, which is 30. So this is going to be $70. See? Lots of times when there are piecewise functions in the world that you didn't even think about. Now, you plan to sell shark t-shirts as a fundraiser. The wholesale t-shirt company charges you $10 a shirt for the first 75 shirts. The company charges $7.50 for between 75 and 150 shirts. Then when you purchase 150 shirts or more, each additional shirt beginning with the 150th shirt is only $5. Write a function that models how much it costs to purchase the shirts. Well, $10 per shirt if you're up to and including 75 shirts. Over 75 shirts, you got to pay for the first 75, then it's $7.50 for all the others. Where did I get the $7.50? Okay. 75 times 10 is 750. That's where this came from. Okay, right here. Now, the next one is the one that's a little bit crazier, a little bit more to it. This one is a crazy equation. That's anything over 150 shirts. Well, you paid $10 for the first 75 shirts. Then you paid $7.50 for the shirts between 149 and 75. That turned out to be 555. You only pay $5 for every shirt over 149. These first 149 are taken care of here. So you multiply, you add $7.50 and the 555. That's where the $13.05 comes from. Now, how much will it cost you to order 50 shirts? Well, 50 falls in this first category. So 10 times 50, it's going to cost you $500. How much will it cost to order 120 shirts? Well, 120 shirts gets a little crazier. You've got 750 plus $7.50 times the 120 minus those first 75 shirts for a total of $1,087.50. This amount should be less than this number. Otherwise, you're doing something kind of crazy wrong. How much will it cost to order 200 shirts? You plug the 200 in, and if you've got a calculator handy, you just type in the 5, you do the 200 minus the 149, and don't do something crazy like I have done before and accidentally hit too many zeros. And then don't forget to add the $1,305 for those first 149 shirts, and you wind up with $1,560. Piecewise, the way you calculate the cost of the shirts is different depending on how many shirts you order. Little more practice evaluating. F of -3, and I've even color coordinated these to be nice. -3 is less than 0. It's a constant function, so it's -2. You can even think of this as plus 0x. So if I put -3 in, -3 times 0 is 0, plus -2 is still -2. F of 0, 0 is not less than 0. 0 is equal to 0. So here I get 0 plus 1. The answer is 1. 5 is squarely between 0 and 5. So this is 5 plus 1, which is equal to 6. 10 goes in the center. X is less than or equal to 10. So therefore, again, this is 10 plus 1 is 11. 12 is more than 10. So this becomes -1/2 times 12 plus 16. That's -6 plus 16. The answer here is 10. You've got to figure out which piece it goes with, which part of the domain is the input in. Okay? Now, try this one. Pause the video and try this one. Okay, take a look at each one of these. How did you do? I threw a sneaky one in there, F of 15. Well, 15 doesn't belong in the red, the blue, or the green. An input of 15 is not defined for this function. Okay? If you think about it, I ask you, what grade should a 32-year-old person go to in public school? They shouldn't go to public school. They can't go to public school. They've aged out. There is no grade for them. Sometimes it's outside of possibilities. When it's outside, it's undefined. I know, sneaky. Okay, last group, pause your video and try these. Determine the piece based on the domain restrictions. Use the function defined for the domain containing the input to calculate the range value for the given domain value. Pause the video and try it. Okay, you're back. F of -3 equals -2. F of 0 goes in the second piece. It equals 1. F of 5 goes in the second piece. Equals 6. F of 10 still goes in the middle piece. Equals 11. F of 12 goes in the last piece, and it equals 10. Now, because this is less than 0, greater than 10, and everything in between is covered, there won't be anything undefined for this function. Summary: a piecewise function is a function that is defined differently for certain pieces of its domain. To graph a piecewise function, create a table of values for each equation using endpoints that cover all the pieces. Watch the open dot, closed dot, or arrow at ends. Piecewise functions are not all linear. Be careful. They could be quadratic. They could be absolute values. We're going to look at some of those later in this unit. To evaluate a piecewise function at a given value, determine the piece to use based on the domain defined for that piece. A piecewise function is evaluated only once for any given value. A function means for a given input there's one and only one value. Answer.